In this video, I'm going to go into some detail on the real number system. Basically, all the different classifications of numbers that fall under real numbers. And to do this, we're going to look at this graphic here that helps us kind of organize each of the different types of numbers that you'll see in the real number system. I should note that for the Pennsylvania Keystone exams, you only need to really know in the real number system the difference between rational and irrational numbers. Now, if you're an Algebra 2 student or beyond in Pennsylvania, then you may need to know these for your class. So I'm going to go into all of them, and you'll probably need to know this in a later math class, even if you're only an Algebra 1 student right now. So here we go. We've got the real number system. This encompasses most numbers you're familiar with up until this point. There's actually another set of numbers, if you're curious, called the imaginary numbers, which you'll get into in Algebra 2, but for now, don't worry about that. Let's assume all numbers are real numbers. Okay, so natural numbers, we'll start on the innermost kind of ring here. The natural numbers are just counting numbers, like 1, 2, 3, 4, and so on. You know, if we kind of kept going there, counting forever. Any number you could count to starting at 1 would be a natural number. Okay? Now, there's one classification that's not included here, so I'm going to sneak it in here real quick, the whole numbers. And the whole numbers are exactly the same as the natural numbers, except you're adding 0. So the whole numbers, or any whole number, is really just a natural number. The only whole number that's not a natural number is 0. Okay, and 0 is actually kind of a big deal when it first was kind of introduced into the number system. But anyway, now we're going on to integers. Integers are just positive and negative whole numbers. So imagine we have all these natural numbers and 0. So we've got, 0, 1, 2, 3, and so on forever. And then if we go backwards here, we also could have negative 1, negative 2, and so on. So any positive or negative whole number is going to be an integer. Okay, so for example, negative 500 is an integer because it is a whole number and that is positive or negative. In this case, it's a negative version. Now, negative 500 is not a whole number because it's not anything from 0, counting up to, however high you want it to count. Same with natural numbers. It's not a natural number because it's negative. Okay. Now, 3 would be an integer, a whole number, and a natural number. More on that in a little bit. Now, the definition of a rational number is any number that can be written as a fraction. It may not necessarily appear to be a fraction, but a rational number is any number that can be written as a fraction. For example, we could do something like 3 over 2. That's a rational number. We could do negative 1/7. That's a rational number. Actually, 10 is a rational number. You might think, well, wait, that's not a fraction. Of course it is. If you write 10 as 10 over 1, it can be written as a fraction. We could also do something like 0.7. Okay, 0.7 is also a rational number because if you were to take this, you could also write this as the fraction 7 over 10. Okay, so these are exactly the same thing. Let me see if I can think of another example here of a rational number that you might need. We could do 3.5. So again, 3.5, we could change that to an improper fraction if you want. 3 times 2 is 6, and if we add the 1, that's the same as 7 over 2. So any number that can be written, it's in the form a over b, where a and b are integers, is a rational number. Okay? And then we'll go ahead and get to real numbers. There's a little caveat on that in a little bit. But so real numbers, these are all real numbers here, all of these numbers that we just talked about. And any rational number, any natural number, whole number, or integer is a rational number. So they're all encompassed. This kind of concentric circle contains all the other numbers inside of it. Now, there's another classification of numbers in the real number system that we'll talk about as well. These are irrational numbers. So let's take, for example, the square root of, let's go with 15. Okay, and if you take the square root of 15 in your calculator, I don't have my calculator handy, so I'm just going to guesstimate about what this is here. This is going to be about 3 point, I don't know, let's say 83, something, something, something. If it looks like it's going on forever, and it's a non-repeating, meaning it doesn't seem to have any distinguishable pattern, non-terminating decimal, such as an uneven square root like the square root of 15, this is an irrational number. Okay, so the square root of 15, if you punch it in your calculator, it doesn't terminate, meaning it's going to keep going on forever. It runs to the end of your calculator and would keep going on forever. And it's not repeating. There's no distinguishable pattern. Okay, so again, another example of an irrational number would be the square root, and let's throw a negative sign in here just for good measure, the negative or the opposite of the square root of 21. Pi is a common example that people bring up because pi also goes on forever and there's no distinguishable pattern. It doesn't repeat. Now, that's going to have caused me to throw another number up here under rational numbers, a number that does repeat and is a decimal. Like let's say, make it easier. Let's go 0.3 repeating. That is a repeating decimal, even though it doesn't terminate and it goes on forever. That can be written as 1/3. Okay, so any fraction or any decimal that repeats can be written as a fraction. All right, so that takes care of all the different classifications of real numbers. Again, if you're looking only for the Pennsylvania Keystone exams, you only need to know the difference between a rational number and an irrational number. So if you can tell the difference between rationals and irrationals, you're good to go. Again, if you're in Algebra 2 or maybe a later math, you may still need to know this depending on your teacher. Okay, now we're going to classify these real numbers and name the set or sets of numbers that they belong to. So we'll start here with 1. We know that if we look back here real quick, 1 is a natural number, it's a whole number, it's an integer, and it's also a rational number. So we're going to write these down, and I'll abbreviate this just to save time. So we've got natural number. There are symbols for all these, but I won't go into those in this video. Natural numbers, we've got whole numbers, we've got integers, and of course, if it's all of those, it has to be rational. Okay, so we got natural, whole, integer, rational. Now, next one, number 2. This is also going to be a rational number. Again, it's not a non-repeating, non-terminating decimal. So -7 is going to be, it won't be a natural number because it's negative. It won't be a whole number, but it's going to be an integer. And it's going to then, of course, be a rational number. 0, okay, 0 would be a whole number. It's not a natural number because we don't include 0 in the natural numbers. It's an integer then. And all the things outside of here, it's also going to be a rational number. Okay, moving right along. 1.9, this is a decimal, so this is rational. But it's a decimal that does terminate, so it doesn't go on forever. It's not, and it doesn't seem to repeat or anything anyway. So it's a rational number. Again, you could write this as the fraction 19/10. Okay, that's the fraction form of 1.9. The square root of 27. Now, if you punch this in your calculator, again, I don't have a calculator in front of me, so my number might be a little off. This is going to be a little bit over 5, maybe 5.2 or something like that. And if you look, that's going to just repeat and go on forever. It doesn't seem to have any distinguishable pattern, so this is an irrational number. So I'm going to put an I with 2 R's here to represent irrational. Okay, and then number 6 here. If we have the opposite of the square root of 36, you might think that this is irrational because it has a square root. But take a second. The square root of 36 can be simplified to 6. And then we'll just take the opposite of that, so that's -6. So this is actually just an integer and a rational number. And last but not least here with number 7, we'll talk about pi. Pi goes on forever. And it doesn't seem to have any sort of distinguishable pattern here. So this is also an irrational number like number 5 because it is a non-repeating, non-terminating decimal. All right, and just to sum things up, I've kind of summarized a lot of this into just kind of a little notes page. If you want to take a second and pause this and take some notes or take a picture of it, feel free to, but this is just here for your resource.